All right, let's solve exponential equations this time. So the first video, we focused on solving the logarithmic equations on page 1 and 2. I asked you to try number 1 and 5 on the daily problems. And I kind of gave you a suggestion on how to start number 5 at the end of the video. Now, in this video, we will solve exponential equations, okay? Step to solve exponential equation by using logarithms. So, when you have exponential equations, in other words, what I mean by that is, because we don't consider, say, suppose you have something like x cubed equals like 24. We don't consider that to be an exponential equation. What I mean by exponential equation is that you're going to find your variable that you want to solve for in the exponent's position. So if you have variables in those positions, what you're going to have to do is you will have to use the logarithm to bring those guys down. Okay? So number 1, isolate the exponential expression on one side of the equation. Number 2, we're going to take a logarithm of the same base on both sides of the equation. Usually, we will take natural log of both sides. You can take common log of both sides too, but I tend to just take natural log of both sides. Number 3, we will use the power property of logarithm to bring down any exponents. And number 4, we will solve the resulting equation. It's easier than what it sounds, so we'll get to it. Let's get started on it. They said solve for y in the equation below. Solve for y or x, because number 1 has y, number 2 has x, I see. We will round the answer to the nearest 100. Do not round any intermediate computation. So I'll ask you to do this too. Write down the exact solution and get the decimal approximation rounded to the 4 decimal places. So let's start with number 1. As you can see, the exponential expression is isolated by itself on the left. It says 12 raised to the 4y power. Now, what I'm going to do to both sides is I'm going to take natural log of both sides. You can take common log of both sides. That's up to you. But you're going to get the same answer. So take natural log of both sides. You will get natural log of 12 raised to the 4y equals natural log of what? 15, right? All right. After that, what you're going to do is you're going to bring down the exponent, any power, using the power property. So if that comes down, you will have 4y times natural log of 12 equals natural log of 15. Okay? Now remember, we're solving for y here. So if I want to solve for y, I would just divide both sides by 4 ln 12 on both sides. But let me take care of one thing at a time, okay? Let's just divide it. Because if you see what I mean, 4 times y times natural log of 12, right? I can divide both sides by 4 times natural log of 12. 4 times natural log of 12. To cancel out this 4 and this natural log of 12. So now we got y equals natural log of 15 divided by 4 times natural log of 12. And that is the answer. We got the exact solution. And if you want to find the decimal approximation, all we need to do is just type this in our calculator. ln 15, 4 times ln 12. Let me go to my calculator. ln 14, clear. In a fraction format, ln 14 divided by, oh no, forgot. ln 15, 412. ln 15, 412. Clear everything. ln 15 divided by 4 times natural log of 12. Now, the answer is 0.2724. I want to show you something else, though. Because, remember I said you can choose to take natural log if you want. I like natural log just because. But you can also take a log of both sides. So let me try to do that too. If I do the log of 15 divided by 4 times log of 12, guess what we get? We get the same exact answer. So up to you. If you like log, if you like natural log, just use the one that you like. Okay? And for me, both are correct. The decimal approximation is 0.2724. So that's what I mean by I want the exact solution and the decimal approximation. So this week, when you guys submit the classwork, you have no idea what I mean by exact solution and decimal approximation. I know who's watching and who's just trying this on their own. So please give me the exact solution and the decimal approximation. Let's try a couple more. Okay. 3 raised to the 3x minus 1 equals 6. You know my thing. I take natural log of both sides, and I'll continue to do that. Natural log of 3 raised to the 3x minus first power equals, the right side, take the natural log to ln natural log of 6. Now, the reason we did that was because we wanted to bring down that exponent in front of it. So if I bring that down, I will have 3x minus 1. Put that in a nice parenthesis because that is a binomial. And that's getting multiplied by ln 3. And then I have ln 6 on the right side. Now, it's up to you. You can distribute both sides if you want. Or we can just solve it by subtracting natural log of 3 on both sides. I think a lot of people like distributive property. So why not? Why don't we distribute this natural log of 3? Okay, we can. But we can divide both sides by natural log of 3 if that's what you want. I kind of want to do that. You know why? Let's do that. Sorry, I changed my mind, but I think we're going to see something cool here. Okay. So you know what? Never mind. It's not cool. I thought I could use the quotient property, but they need to be subtracting. So you know what? That's not right. I got 3x minus 1 equals natural log of 6 divided by natural log of 3. And I'm just solving for x, right? So what do you do to both sides? Add 1 to both sides. So I have 3x equals natural log of 6 divided by natural log of 3 plus 1, right? And then I need to divide everything by 3. And that's going to be a little messy. I kind of regret that I could have taken the square root. But that's okay. I can multiply both sides by 1/3, right? So then x equals natural log of 6 over natural log of 3 plus 1 times 1/3. And that's a fine answer. We're just going to type that in our calculator. But I just think it would have been easier or a nicer looking answer if I take the distributive property instead of dividing by natural log of 3. So let me go back. Nothing wrong with that answer that we just got. But I feel like it's going to be a prettier answer if I distribute. So let me distribute, okay? So if we distribute, we will get 3x times ln 3 minus 1 times ln 3. 1 times ln 3 equals ln 6. What will you do to both sides? You will add natural log of 3 to both sides. Then you will have 3x times natural log of 3 equals natural log of 6 plus natural log of 3. We can combine that to be what? Natural log of 9, right? But anyways, I can go ahead and now divide everything by, this looks much better. 3 times natural log of 3. I can divide this by 3 times natural log of 3. And the reason I'm doing that, because I want this 3 gone. I want this natural log of 3 gone. Therefore, the final answer is x equals, I do want to combine these numerators. You see what I mean? These are sum of natural logs. I can write that as natural log of, not 9, 18. Because you have to multiply. You have to multiply the arguments. And then I will have 3 times natural log of 3. Therefore, that's my final answer. That is my final answer. And if I want to get the decimal approximation, we can do that. Let's go to the calculator and type this in. This one was fun. Hold on a second. Because I know what's going to happen. If I close this app, I will forget what I want to type in my calculator. So I took a picture of this, going to my calculator and type in fraction, natural log of 18 divided by 3 times natural log of 3. If I hit enter, I will get 0.876976. So let's just go ahead and round that number to the fourth decimal places. Where did my notepad go? Right here. 0.876976. 6. Oh, it's awkward because it's 697. It's going to round up to 70. So the rounding was a little bit awkward, but that's okay. I got the 4 decimal places, and that's what I wanted. These log expressions are taking a little bit longer. I'm sorry, not log. Exponential, but that's okay. We're doing all right. All right, let's do 3 and 4. Where I have more fun exponential equations. So what do? You take natural log of both sides. Natural log of e to the x plus 1 equals natural log of 4. If you bring this exponent down in front of it, you will have x plus 1 times natural log of e equals natural log of 4. I want you to type something in your calculator. If you remember the log property, one of the log property. What is natural log of e? What's that going to be? Natural log of e is going to be simply 1. Okay, natural log of e is just 1, and that just happened here, so that will just kind of cancel out this because this is just 1. So what we got is, I don't even need the parenthesis anymore, x plus 1 equals natural log of 4. So if I want x by itself, I got my answer. X equals natural log of 4 minus 1, right? Now, you know why I'm not checking the answer here? You know, unlike the log expression, what was the domain of an exponential function? All real, right? So whatever kind of crazy answer that I get, exponential functions can take it. Their domain is always all real. So I don't really have to check for solution. I know anything that looks crazy, if I plug in, it's going to be okay. Unless I made a mistake on like solving somehow. But okay, checking is always a good way, is always a good habit, but it's not like required for the exponentials. I will say I want you to always check your answer for the logarithmic, but if you're solving exponential equations, you can skip the check part. All right, let's type in natural log of 4 minus 1. Let's type in natural log of 4 minus 1. What's that going to be? That's going to be 0.3863. Round that up to the nearest. What's that going to be called? 100,000? No, I don't know. 4 decimal places, I'll just call it. Okay, go back to my notepad and let's write the answer. X equals 0.3863. So that's the decimal. That's approximate, right? And this is the exact. So give me both when you're solving 3.5 problems, okay? All right, last one on page 3. They're taking longer than I thought, but that's okay. It's fun. All right, let's solve this. But before I take natural log of both sides, do you see what we can do to both sides? Absolutely, right? We can subtract 820 from both sides. Let me move out of the sun. I was sitting in the sun and it's getting hot. How you guys doing? All right. I moved to my dining room now. Okay, let's solve this. I'm going to subtract 820 from both sides. If I do that, I'll get 10 to the 8 plus 2x power equals, getting my calculator to do 49,600 minus 820, and that got me 48,780. All right, you know, I love taking natural log of both sides, but this time, I don't think I will do that. You know why? What's the base here? The base is 10, right? So instead, you know, I love taking natural log. I'm going to take log, common log of both sides. And you kind of see why that I'm doing that, right? I'm going to take common log of both sides. Why am I doing that? Well, first of all, let me bring this exponent in front of it, okay? That's going to be 8 plus 2x and log 10. And that equals log, that big number, 48780. Check out what this is real quick. What is log 10? This was one of the properties that we talked about, but log 10 is nothing more than just 1. So just like natural log of e is just 1, log 10 is just 1. So because this is just 1, I got 8 plus 2x equals log 48,780. And then let's go ahead and subtract 8 from both sides. Then I get 2x equals log 48,780 minus 8. And then if I divide everything by 2, I got my final answer. Log 48,780 minus 8 divided by 2 is my final answer. I don't know why I picked such a big number here, by the way. But anyways, let's get the decimal approximation of that, okay? Who knows, maybe it is a very nice number. I don't think so. All right, but let's go ahead and type this in our calculator to get the decimal. All right, calculator. Fraction, we had common log 48,780. Close the parenthesis and subtract 8. And that's getting divided by 2. Oh my goodness. It's a decimal. It's a negative 1.65 blah blah. So let's go ahead and write that down as the answer. Oh no, I keep pressing my picture up. Okay, so x equals, or I should say x is approximately negative 1.6559. So I got the decimal approximation and the exact answer all over here, okay? Okay, so done with page 3. On the exponential equations that I prepared are a little bit more challenging, but they're fine, right? You either take natural log of both sides or common log of both sides, bring down the exponent and just solve for that variable, okay? The good thing was that we really didn't have to check the answer because the domain of an exponential function is going to be always all real. So unless the left side equals the right side, we got the right answer. All right, let's do the last page. Now, solving an exponential equation by finding common bases. Now, you know, if you were okay with the first 4 problems that we just did, you can keep on taking that method, really. You really don't have to consider this method, but I still want to show you how sometimes this method really works. Okay, so just the 2 problems, though. All right, if you take a look at this, I'm not going to take natural log of both sides because I want to show you something. Well, you see the bases here are 3 and what? 27. 27 can be rewritten as 3 to the 3rd power. So I'm going to use that to solve this equation. 3 raised to the 3x power equals. So I'm going to replace the 27 as 3 to the 3rd power. And then just keep the other exponents in a nice parenthesis. So you notice, will we get the wrong answer if we take natural log of both sides? No, definitely not. But sometimes you can rewrite the base so that you can write the common base to solve it this way. But you know, that probably wouldn't work on, yeah, like 12 and 15, there's no common base. 3 and 6, there's no common base. But 3 and 27, I could write the 27 as a 3 to the 3rd power. So that really worked. Now, if you take a look, I can set 3x equals that 3 times 2x minus 4. So let me do that. 3x equals 3 times 2x minus 4. So this does happen on, you know, some of these, not very frequently, but if you notice that you can rewrite these bases, then that's another good method of solving it. All right, so I distributed it. Let's go ahead and subtract 3x from both sides and add 12 to both sides. I will get 12 equals 3x. Therefore, x comes out to be 4. So if I plug in 4 into the left and the right side, both sides will check out. So that's one method. That's another method, but that doesn't happen all the time. So the backup plan is you know how to take natural log of common log of both sides. All right, let's look at this one. Let's see how this one is not too obvious, right? So if somebody's looking at the bases like 64 and 32. See, honestly, when I see the number 64, I think of 8 times 8. But how's that 8 gonna help us with 32? So let me go ahead and give you the hint here. Raise 2 to the 6th power. raise 2 to the 6th power. What's that going to be? 2 to the 6th power is 64. What about 2 to the 5th power? If you do 2 to the 5th power, that is 32. So what we can do is we can rewrite the 64 as 2 to the 6th power, and we can rewrite the 32 as 2 to the 5th power, and keeping the original power in a nice binomial parenthesis. And we can go ahead and not take the natural log or common log of both sides. But if you didn't notice that 64 and 32 can be rewritten with the common base of 2, that's okay. You probably just have to take natural log of both sides and solve it the way that we did the first 4 problems. There's nothing wrong with that. But just kind of wanted to show you a different way that sometimes these methods work. 6 equals 5 times negative x minus 3. If I distribute, I will get 6 equals negative 5x minus 15. Let's solve for x here. If you add 15 to both sides, oh no, I'm going to get 21 equals negative 5x dividing by negative 5. We got a decimal answer or fraction, 21 over 5, a negative. But that will be fine. There's nothing wrong with that. So if you want to check your answer, just out of curiosity, type that in for me. 32 raised to the negative 21 over 5 and minus 3. Let's try that real quick, and I want to see if that comes out to be 64. Okay? 32 raised to the negative 21 over 5, and then I subtract 3. When I did that, I got 64. This came out to be 64. So nobody's stopping you if you want to check your solutions. I think that's always a great practice. But just want to make sure that you are checking your answers for all the logarithmic equations, because you may get extraneous solutions in those problems, okay? Now, we only got 2 more left. All right, I guess if Algebra 1 was all about solving linear equations with variables on both sides, and in Algebra 2, you started solving these quadratic equations using quadratic formula, completing the square. I guess our class, we're having so much fun solving exponential and logarithmic equation. So I hope you're enjoying these equation solving. We're left with the very last one. All right, take a look at the bases, 13 and 8. Is there a common base that we can convert 13 and 8 into? Not really, right? So guess what? We're going to go ahead and take natural log of both sides. Natural log of 13 to the negative 10x power equals natural log of 8 raised to the negative x minus 10th power. The reason we're taking these natural log is because we do get to bring down these exponents in front using the power property. So that I will have negative 10x times natural log of 13 equals negative x minus 10 times what? Natural log of 8. All right, we're going to solve for x here. I'm going to distribute the right side. I'm going to distribute the right side. Okay, then I will get negative 10x times natural log of 13. Nothing changed on the left side is equal to negative x times natural log of 8 minus 10 times natural log of 8. I just wrote natural log of 8 next to negative x and negative 10. Now, what I'm going to do is I'm going to search for all the terms that have x, and I'm going to move them to the left side. That term has x. This term has x, right? So these two belong to the left side. I'll have negative 10x times natural log of 13. Nothing changed about that one. But in order for me to move that, I'm adding it, right? So add x times natural log of 8. And that equals the only thing left on the right side, negative 10 times natural log of 8. Why did I move all the terms that have x to the left side? Because I wanted to factor out the x. Let's go ahead and factor out the x. They both have x, so bring that x out. X is outside, so the first term is left with just negative 10 times natural log of 13 plus natural log of 8. And that equals negative 10 times natural log of 8. You are one step away. Can you see? We're going to divide both sides by negative 10 times natural log of 13 plus natural log of 8. And that side too. Negative 10 times natural log of 13 plus natural log of 8. And cancel. X equals, I just got to write it one more time. Negative 10 times natural log of 8 divided by the sum of negative 10, natural log of 13, and natural log of 8. That is the answer. So what you want to do is you just want to make sure that you type that in. I know it's not the prettiest looking answer, but it is the most accurate answer, okay? So we're going to go ahead and type that in our calculator to get the decimal approximation at this time, okay? So open a fraction. Negative 10 times natural log of 8 divided by negative 10 times natural log of 13. Close the parenthesis and add another natural log of 8, okay? If I hit enter, I get the decimal answer to be 0.8822, okay? So that's going to be the answer, and that's how you solve these type of problems. They will take a little bit longer, but it's okay. 0.8822 is the final answer. Now, because I know there are cool calculators out there that you can just type these answers in, and I think some of them kind of do give you the work, the process of solving them too. So, but if you're just using these online calculators, I want you to make sure that you know how to solve them, because you're not just, after this class, you're going to have to go up to the calculus class, and you want to know how to do these by hand. You really do. All right, let's do the very last one, and I will wait for your 3.5 problem submissions, okay? All right, the very last one. I got 4 raised to the 2x minus 7th power equals 5 raised to the 3x plus 1st power. 4 and 5, they cannot be rewritten in a common base. So what I'm going to do is I'm going to just go ahead and take, why not, guys? I've been taking natural log all this time. I'm going to be different and take common log of both sides, which is going to be the same, okay? So don't worry. If you like common log, take common log. Log of both sides. And why are we doing that? Because if you do that, you can use the power property to bring down your exponent. That's going to be 2x minus 7 times log of 4, okay, equals 3x plus 1 times log of 5, right? All right, distribute log 4 and log 5 to both sides. You're just going to distribute this number to these two terms and distribute that number to these two terms. So I will get 2x times log 4 minus 7 times log 4 equals 3x times log 5 plus 1 times log 5. What you're going to do now is search for all the terms that have x's. This term has x, no x. This term has x. So if it has x's, I'm going to keep them to the left side. I'm going to send them to the left side. I will have 2x log 4. Notice what I circled on the right side has a positive sign, so I'm moving that. So now that's going to be 3x minus 3x log 5 equals, now I didn't say that I was going to move this, but I should move it. Why? Because it doesn't have the x to it. So I'm moving that to the other side. So the right side will turn into log 5 plus 7 log 4. Okay? All right, why did we do all that work? Because you want to factor out the x. So left side, factor out the x, and you're going to have 2 log 4 left minus 3 log 5. And the right side stays the same. It's just waiting for right now. Because what are you going to do now? You're almost done. You're going to divide both sides by 2 log 4 minus 3 log 5 on both sides. So you are done. The final answer is x equals log 5 plus 7 log 4 divided by 2 log 4 minus 3 log 5. And the answers will look like this. They just look so difficult, but you know they're not difficult. They're just expressions, right? So you ready to type this in the calculator with me? All right, let's do that. So go to the calculator so that we can get the decimal. So fraction bar. On the numerator, let me do log 5, close the parenthesis, plus 7 log 4, close the parenthesis, go to the bottom. Do 2 log 4, close the parenthesis, minus 3 log 5. Minus 3 log 5. Close the parenthesis. So, just double checking what I entered. Yes, that looks good. I don't see any mistake. I hit enter. The answer is negative 5.5034. So we got it. We did the very last problem. All right, let's go ahead and write our very last answer on our notepad. Where did you go? Right here. The answer is negative 5.5034. And I like how we got both the exact answer and the decimal approximation written. So that's what I want you to try, because I think you can now. Let me go ahead and just, I will post these on Canvas for you so that you can see what we did together. But I know some of you just read the notes and then just come and try the problems on your own. Oh, forget this. Come and, look at the video whenever you get stuck. That's okay, as long as you're keeping up with the work. I'll wait for your submission, and I'll be excited to grade and give you feedback on any steps that you're missing or things like that. But now you're really ready to try number 2, 3, and 4. Make sure to please show work. Give me the exact value and the decimal approximation. And the exact values will look something as ugly as what? Like these. But that's okay. That's what I want. Okay? All right. That's it. And look, 3.6 is going to be the last section of Unit 3. So you're almost done with Unit 3 too. So we're thinking exam 3.